In this video, we're going to practice a couple proofs that prove two triangles are congruent using the side-side-side congruence theorem. So remember, the side-side-side congruence theorem says that if you have three sides of one triangle congruent to three sides in a second triangle, you know the two triangles have to be congruent. And so you should have a proof workbook, and we're going to do a couple proofs out of that proof workbook. So the first one we're going to do is the proof for side number one. Now you are given kind of a word bank down here. I'm going to encourage you to try not to use that as much as possible. So it says, given line segment PQ is congruent to line segment ST, line segment QR is congruent to line segment TR, and R is the midpoint of line segment PS, prove that triangle PQR is congruent to triangle STR. And so I know I'm going to go and put in some of my given statements into my proof. So one given is that line segment PQ is congruent to line segment ST. So I'm going to add that into my picture since they didn't have that labeled for me. All right, my second given is line segment QR is congruent to line segment TR. We also know that R is the midpoint of line segment PS. And so I'm going to add that statement into my proof. R is midpoint of line segment PS. Do not forget to add that into your proof. We know at the end we are trying to prove that these two triangles, triangle PQR, is congruent to triangle STR. And so it's my job to now fill in the missing information to try to prove that those two triangles are congruent. So looking at what we have right now, we have one pair of congruent sides and two pairs of congruent sides. Now we know that we're going to be using side in this proof, and so we're trying to find or justify this third pair of congruent sides being congruent. So let's go back to this given statement that we haven't really used yet. R is the midpoint of line segment PS. Remember, midpoints cut a line segment into two congruent segments. So if R cuts line segment PS in half, that must mean line segment PR has to be the same length or has to be congruent to line segment SR. And so because R is the midpoint of line segment PS, we can conclude that line segment PR has to be congruent to line segment SR. And our reason for that is the definition of midpoint. We use the definition of midpoint and the fact that R was a midpoint to determine that those two segments were congruent. So now I have three pairs of congruent sides in two of these triangles. And therefore, I can say that triangle PQR is congruent to triangle STR by the side congruence theorem. Let's turn in our proof book to page 2. We're going to do one more side proof. All right, our first given. L is the midpoint of JN, line segment JN. We are also given that line segment JM is congruent to line segment NM. That is another thing that is given to us. And I know at the end I am trying to prove, that triangle JLM is congruent to triangle NLM. So this time in this proof, I have less information to start out with, meaning I only have one pair of congruent sides right now. Oops, not there, sorry. I only have one pair of congruent sides. I know I'm going to have to find some more pairs of congruent sides. Let's go back and let's use the fact that L is a midpoint. In our previous example, we said midpoints divide line segments into two congruent pieces. So if L is a midpoint, I know by the picture it doesn't quite look like a midpoint, but we don't go based on how the picture looks, we go based on the information given to us. L is a midpoint, therefore line segment JL has to be the same length or congruent to line segment NL. I'm going to add that as a statement. Line segment JL must be congruent to line segment NL by the definition of a midpoint. So that helps me get a second pair of congruent sides. Now I need a third pair of congruent sides. What I notice, and hopefully it stood out to you, is that these two triangles, they share a side. They touch along line segment ML. Well, if they share that side has to be congruent to itself. I know that line segment ML on this triangle has to be congruent to line segment ML on this triangle because it's the same exact line segment, and anything has to be congruent to itself. That property that says something is congruent to itself is the reflexive property. And so from there, I've got three pairs of congruent sides in these two triangles. So triangle JLM is congruent to triangle NLM by the side-side-side congruence theorem.